Hey everyone, this is the first practical video in my Mastering Reusable Solutions for Revit plugin development course slash playlist. You can find all videos about this in the playlist that has the same name. Since I decided to go really in depth in how to create reusable solutions, and it's not that constrained to Revit, but I'll show you a lot of examples with Revit, and everything will kind of revolve around this. But since I decided to go in depth, I want to make sure that you have some prior knowledge, some understanding of some topics that are vitally important, that are crucial to get into the depth of all of these topics that you see in front of you. So in this video, we'll explore the foundational blocks of data organization. So this is called data structures. I'll introduce you to the IEnumerable interface in C# and show you the uh, how how the pattern works and how it was implemented in C#. I'll also show you some kind of code under the hood. So what your C# code compiles into the IL code or low-level code, so you can understand how some things works. So you'll definitely see that how for each, what for each is compiled into, so you understand what actually happens behind the scenes, and you'll understand why IEnumerable is pretty flexible, and we can use it, and we can iterate over IEnumerable the same way, even though we may have different kinds of implementations. We may have dictionaries, lists, and other stuff. Yeah, also before diving into this, if you want to check out my paid courses about Revit API, you can follow the link that you see in front of you. Again, don't feel pressured. I do put a lot of content on YouTube for free. So this is for the ones who really want to go in depth and master uh, Revit API, starting from the very basics to the advanced topics. So yeah, thank you for staying with me on this journey, and let's get started. We're gonna start by looking at the geometry element first. So this is the instance of this class you get when you call geometry property on the Revit's element. So we can say that each Revit's element has a geometry, and this geometry is of type geometry element. Right away, what we can see is that it's an IEnumerable, it implements an interface, IEnumerable, of geometry object. And before even getting into like nitty-gritties of the geometry element and how geometries are represented within Revit system, we're gonna understand what is IEnumerable, a little bit about data structures, and how everything goes. So let's get started by just switching to the whiteboard and start drawing something. Let's think about a general kind of like Revit, right? Because that's something that we can relate to. That is relatable to us. Usually Revit is just a representation of data, right? And it actually goes for a lot of things, almost all applications that we see. Everything is about data. And if we think about Revit and look at its document, we can say that Revit is, let's suppose we have a model that contains walls, right? Let's say it just contains walls. So walls, this is a data, right? So I'm not gonna draw actual walls. I'm just gonna mark them as letters, right? So let's suppose we have a bunch of walls in the model. So let's imagine that this is a Revit document, right? That this is a Revit document, and we have a bunch of walls in there. So each of this wall is practically just a data that we operate within Revit system, and it can be numbers, it can be text, it doesn't matter. All these things are just about data. But usually, what we need to have for this data, right, is that we need to have some containers that can hold it, right? So we need to have a way of organizing them. So this data should be organized somehow. Um, a very simple example is that we can organize them linearly. So you can, if you think about going to a shop, going to a mall, or any other place where you may buy things, right? You usually have a bag of something where you put things, right? And this bag acts as a container. So the same goes here. Let's suppose that we want to have them linearly, right? And we just have each wall stored like this. I'm going to just separate them by these straight lines like that, right? Something like this. So we just have a linear representation of the wall of walls. And if you're familiar with programming, and I hope you are, just a bit, this is what is usually an array represents. So array, right? Array is basically a container that allows us to store elements linearly. So you just have a way of representing this, right? A way of creating a container for the data that you operate on. But you may have different ways of organizing things because even if you think about different examples in the real world, again, you have a bunch of things, your clothes, any kind of objects around you, you always organize them in some way, right? You're not just putting them randomly. Sometimes it's a very complex hierarchical organization, so you can easily so you can easily grab something, right? So usually, especially when it comes to a bunch of papers and documents, you even have a very sophisticated organization of them, so you can quickly grasp items that you need. The same goes here. Again, try to draw these analogies to real world things, and they will help you understand concepts better. So this is the way I try to learn things, is that I kind of connect it to stuff that I'm already familiar with. So this is a very simple representation of this. This is usually in programming an array, right? Also list. Let me go back. Array. It's also a list kind of thing, but a list behind the scenes, a list uses an array, and it's more about thinking of a list as a dynamic array, just that it grows dynamically, or shrinks, grows or shrinks dynamically. So yeah. But also we may have, or we may organize data in a more complex way. For example, if you think about family instances in Revit, right? So when you create families, we all know that within Revit we have this concept of creating nested families, right? So that's when one family lives inside another family, and this family that lives inside another family may contain other families as well. So the way we can represent them is not anymore kind of linearly because um, let's go with a very simple example like a door family. So you have a door. Let's suppose this is a door family, right? So you have a door, and door may contain different other families. So it basically may contain multiple nested families, right? So it can be three, four, five, doesn't matter. The amount of them is unknown, right? It can be it's not that is unknown. It's that it's not restricted and it's not constrained. It's about just you may have how many of them you want. And it can have, for example, a panel. Let's suppose you have a panel in there. But inside this panel, you may have other families, like, I don't know, like handle, right? Handle, uh, some other things. I don't know what you may, like how many components, right? What kind of components we would have here. You may think of some more of a complex family, maybe of some kind of structural connection where you have a component that contains a bunch of plates, bolts, and other stuff, right? But the main idea is that this kind of door or any family may contain a lot of nested families, right? And these nested families may contain some other stuff, right? So this is the way it works, right? And this is more of a complex organization of this, right? Format of organizing things, right? And again, try to draw analogy uh, with real world examples that you're familiar with. So again, it's just about having data. In this case, we have families in Revit, and that is a door family. Inside this, we have a panel family, and inside this panel family, we have a handle. And then the main reason why we may organize it this way, so we can quickly access things. Let's suppose you say, I want to get the names of these families and their parents, right? So, for example, you'd want to have like, this is the panel, this is the door, this is the handle, this is the panel. So you would get their names, maybe type names, let's suppose. I don't know, like whatever data you want to get from Revit. The main idea is that they're more complex in structuring it, in organizing, but there is a reason behind this because usually on these types of structuring, we may perform different types of operations, right? So this is like the main idea of like data structure. So basically, it's like a container for data, right? So you kind of put things together, but it's not about just storing them. It's also about like in its core, it's about storing them, but you can also add things to it, remove things from it, right? So all various operations that act on this as a whole, right? So it's more about thinking. So if you have this kind of family structure, this tree for storing families, we would have some operations like inserting elements, right? So you can insert element at a given point. You can remove element. The same goes from this array or any other way of structuring this. So that also kind of imposes and and kind of puts some constraints on it. But two of these approaches, this one and this one, they have the only thing in common, right? So it's all about saying we create containers the way we organize data. So this is the most important thing that we gotta understand from this. So data structures allow us to organize data that our business logic, the application logic revolves around. So in case of Revit, it's walls, floors, roofs, families, and other things that are the heart, that are the part of Revit, right? And that's about kind of organizing them, how we put them, so then we can um, access them easier and perform actions on them as a whole. Now we're one step closer to understanding geometry element. But before this, we also got to understand what is IEnumerable, how does this connect to like data structures and other things that we've learned prior to this, that we've learned so far. Like what is an interface, what is an IEnumerable, and these things. We're not going to go too much in depth, but I just want to make it clear for you so you can continue watching this tutorial with ease. So let me create a solution for this. I'm not gonna write everything in terminal, but usually I do, so it's not very complex for you. But I would recommend getting used to terminal a lot because eventually you're gonna be using this a lot. So that's the reason for this. So I'm gonna be using .NET commands. So .NET new solution. So I want to create a new solution named for the time being, let's call this geometry exploration, exploration app, right? So this is what I'm gonna call, and I'm gonna create two folders: make directory, source, and make directory test. That's usually how I start my app. And you can also create projects with this. But I'm gonna just stop at creating folders and solution. But in future projects, I'll show you like how you can set up pretty much everything from the terminal. My IDE of choice is Writer. You can use Visual Studio or Visual Studio Code. It's all about where you feel comfortable working with, where you feel comfortable working in, right? What environment you feel comfortable working in. So I'm pretty comfortable with using Writer. Uh, so yeah, that's why I choose it. So you can work with Visual Studio. There's no what I'm going to show you here, there's no difference where you write it actually. So what I'm going to do right now is that here I have a solution. Right, I'm gonna put my tablet a bit away. So first of all, I have just a solution. Okay, I have a solution. I'm gonna use shortcuts, Control Shift A to create a new project. You can also right click and go new project. I'll be using a lot of shortcuts, but I'll make sure to explain them because I want to encourage you to work faster, type faster, get used to shortcuts and stuff like this. But before this, actually, let's create also a solution folder. So that's what it would be cool, is that this way we can connect because solution folders is not something that is connected to what you have here in the Explorer. That's more about organization within your environment in code. So that's like, because let's suppose I'm going to create a new solution folder like blah, blah, blah something like this, and then I go there and there's no blah 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 blah, right? We don't have it. So it's more about saying let's organize things within our solution and not in the file explorer. But I don't need this blah blah blah. I'm gonna say also delete it next, and I'm also gonna create test. So I'm creating something similar to what we have here, not actually similar, but the same. The main reason being for this is when I call a new project, the project directory will be automatically placed under source folder, under source directory. So yeah, so I'm gonna name this the same way. So geometry exploration app. Let's name this core for the time being, but it's not that important right now. Let's go with the console application because right now I just want to show you about interfaces, but then we will follow TDD to kind of start from tests. And I'm going to be using .NET Core, not .NET Framework, because right now we're not strictly connected to Revit. I just want to show you things, how that works, and then we'll jump to Revit and see how we can implement it there. But I think that it can be a useful approach for you to take. That sometimes when it comes to learning things that are within Revit ecosystem, sometimes it's better to just kind of isolate yourself from Revit and work here. So I'm okay with going with the .NET 7 version. So that is the kind of a simple console application. And we got to understand, first of all, what are interfaces, right? So this is the first thing that we gotta understand there. And the main idea about interface itself, right, that it gives us a way to kind of put an emphasis the fact that something has a behavior, but we're not actually creating the actual implementation of this. So it's more about saying what is a contract. And I'll show you how that works in Revit as well. So if you go and say public interface, I'm going to write everything so far here, public interface. And let's follow kind of Revit's example, right? So if I go there and if I search for I external command, right? I external command there, that shouldn't be not this one, but this interface, right? So this is what they have. And they say that an interface should be implemented to provide the implementation for Revit add an external command. So they just say that here is the behavior, right, that you need to implement. So if I go back here and I say I external command, right, I external command, and let's have an empty class, right, public class document, right? Uh, so I'm gonna have an empty class there, document, let's suppose, right? And we're gonna say void execute, and it's like we're passing document there, and that's it. As you can see, interface it just provides us like we're not saying how that should be executed, right? So this is something that lives in a separate library, in a separate DLL, in the separate library. In case of Revit, that's Revit API, right? So we could have just created a folder here and put this there. I just don't want to go over this because it's more about explanation. And then you, as a developer, would go and say public class I don't know, create wall command. I don't know, that's a silly name, but and then you go I external command, and that kind of prompts you to implement this interface. So this is the class actually implements this, and this is where you put logic there. So it's like the same with Revit. So Revit provides you with some external data, I think, right? But I just pass here like just document, and you can communicate with document. And then, so let's even put this so it's better for you to understand, so it's easier for you to understand. So if I create a Okay, I gotta go there. And if I create a directory there, let's say Revit AP, Revit API. So let's suppose that that is a different kind of library there. And I'm gonna click Control Shift R. I'm gonna say move to folder. That's what Writer allows me to do. And I'm gonna say I want to move to folder, and I'm gonna put to folder this document and external command, and I'm gonna say next, and they will be there. Again, I'm just using shortcuts. You can do this manually. It's up to you. If you're using Visual Studio, it's all up to you, the way you want to do it. And then you would have like my plugin. I don't know. I'm just gonna call this my plugin for the time being, right? My plugin. And we're gonna put this one again to folder to my plugin, and I'm just gonna call next. And then I have this in my plugin. Actually, let's go next because I don't like this. Sometimes when I do this, that program part kind of disappears. So I'm gonna leave it as here for the time being. Or I think let's kind of move to a separate. Okay, that's nice. And let's gonna move it like that. So I'm gonna manually move this, and I'm gonna just adjust namespaces because right now when I just moved this, it just says geometry extraction Revit IP, but I want this to be kind of my plugin, right? So we gotta change the namespace for this. So now it's geometry exploration app core my plugin, but it's not that important. The main idea is that we have an interface that comes from Revit library. We have our plugin where we implement it. So far, let's just put the in a console a message I don't know, gosh, ho ho ho, I don't know, it doesn't matter. And then within somewhere within Revit ecosystem, what you can think of is that at some place, because you never call this method yourself, right? Have you ever noticed that you are not the one who's calling this? That's something that is called by Revit. And so at some point when you kind of register your like you put add-in files and so on, it doesn't that matter. But the main idea is that these things are called by Revit. And why that works because we have created this interface, which is an abstraction. This is a contract. Revit has no idea about your Revit has no idea about your given class. It reads this on the fly, it reads this during runtime. But the main idea, because that is an iExternal command, this is an interface, it can call this execute method because it's all based on contracts. That's the main idea. So if you were to kind of, I don't know, at some point, I don't know. Let's think that Revit has a method says like get external command, and he goes like external command get external command, right? That is your command. So it reads from the actual DLL, and it does it not like that. It does it like a bit differently, right? Via reflection, but I'm gonna create a main instance of this, right? Like this. But the main idea is that it's just external command, right? So var command, create external, for God's sake, create external, create external, get external command. Get external command, and then it just can call and say execute. And within this case, I'm gonna just create a new instance, but Revit has already its access to the document, right? So this is what Revit does. So in this case, he doesn't know anything about your command and so on. It just I external command. So this is an abstraction. Why am I explaining this? Because that's the same IEnumerable works, right? IEnumerable is also an interface. And when you see that something is an interface, that means that that is simply a contract. So it goes with a bunch of methods that should be implemented by a class. So if I go back and I say uh, public class A, and I say let's implement IEnumerable, I don't know, of integers, right? Let's say we have some silly collection of just integers, right? And I'm go with implement missing members. It tells me that I should have something that returns an enumerator of interface IEnumerable. And if I say public class B IEnumerator, right? IEnumerator, yeah, and something like this. Oops, implement missing members. That has things like that. So it's all about having contracts. So in this given case, to have an IEnumerable, which is simply represents a collection of things, right? So uh, now IEnumerable, that when you see something as an IEnumerable, you understand this right away, that that is something that you can iterate over, meaning that you can go through this. You can use this in a for each loop, right? That is something that you kind of get the idea of. And we create our own enumerables by implementing two of these interfaces. Interfaces are just contracts. So, right, it tells me to implement move next, reset, current, dispose, right? And that's it. So here I could say in this case, return new B, and that would work, right? It would work because I'm returning just IEnumerable, IEnumerator. IEnumerator knows how to iterate over your collection. So as you can see, it says move next. It returns Boolean, meaning whether you can move next or not, and so on and so forth. I don't want to go into into very details of this because it's not the main part of this video. That's not the main idea of it. But the main part, why it's important to understand, is that interfaces allow us to have this standardized way of doing things. And that means if you have lists, if you have dictionaries, you can iterate over them in a standardized way. You can also read more about this in Iterator Pattern, but that's its main idea. For example, if I have a list of things, right, var collection, I don't know, let's name this a list of integers, right, and I'm just gonna have like 1, 2, 3 there. And you can use for each on them, right? So you can use say for each. But um, let me remove these things for the. I'm just gonna comment this out for the time being. What I want to show you there, let's kind of print to the console this. We can run this if you want, right, to see what it prints. That it will print 1, 2, 3 in writer. Okay, that 1, 2, 3. But also what I like about writer that it has intermediate language viewer. And I can have a look at the high level C sharp. I think low level C sharp. Low level C sharp I need. So you can see that for each is about syntactic sugar. Syntactic sugar, it's something that is built by the so that is what developers of the language do, right? So they create things that are interpreted by the compiler differently from what you see. So actually, when you type for each, it actually creates something like this. So as you can see, it goes and says int get enumerator, then say try, while this one is move next, and then it disposes them. So that's why I left it here because as you can see, all of these methods are there. Let me kind of do this part and kind of let me show you what's it all about. So you can, on the collection, because it's IEnumerable, you can actually say IEnumerable, IEnumerable of int, right? So this is your interface. So we're gonna make sure that we're like as if it comes from some method, right? And then you can get enumerator of this collection, get enumerator. Then you can go with try, and for some reason my catch, right? Catch. We don't need to catch there. We just go with finally. We're just repeating what they've done, but you can do this on your own. But the main idea is that they say while enumerator move next, right? and we're gonna say console write line enumerator current, and at the end we're just gonna say enumerator dispose. So we don't want to type this each time. So usually syntactic sugar is built for this reason because we're typing this boilerplate code, something that is so repetitive, and we just do this all over again, again and again. Because of this, they just created this for each kind of syntax that allows us to work with this. We can, if you want, right? I think it would be good to debug it, right? So you can just go there and iterate through things so you can understand this better. So now if I go over this, I get the enumerator, right? And now move next, as you can see, while move next returns what? True. It returns true because it has elements inside a collection. And then we just get the current, and what is the current of this is 1. And then we go move next, and now it's true, and the current right now is 2. And we just go over this, and that's the idea. So that's the main thing of it, right? As simple as that. But what is really awesome about this, I'm gonna just remove this now, that now we can have dictionary, right? Which is not a different way of going through things, right? So that is when we store elements in a different way. We store them in a key value pair manner. So we can have like one, gosh, I'm typing on my laptop and I'm not get used to this uh, right? Something like this. I don't care. Like just a way of structuring data, but we do this differently. And let's say dictionary for each, right? We can do the same thing right now. Just go with the key value pair, and that's it, right? So the main idea that this one is IEnumerable. I think if we go there and even see what it inherits for in implements, right? It has iDictionary. Let me close it for the time being. iDictionary and iDictionary comes from, okay, if we go down this path, it's iCollection of key value pair. I'm not sure I'm gonna go this deep. Yeah, at the end of the day, that's just IEnumerable of T, right? Yeah, so if we go there and say this one, key value pair, but now it represents key and value, right? So even if I build this and I go to IL Viewer, you will see that this is basically the same thing. It goes get enumerator, while that is move next, while this element has, while this collection, while this way of organizing data has anything in it, we're going to continue going and printing this. And when this move next return false, and it returns false when we have no elements inside a collection, we just go and dispose it. Finally, it's going to be called no matter what. So this is the main idea. So how does this relate to the data structures? We talked about the data structures are about like having this way of organizing data. So we can have a bunch of data like walls, floors, and other things, and we can organize them in a linear manner or in a tree manner. It doesn't that matter, right? It can be linear parts, hierarchical trees, key value dictionaries, doesn't matter. IEnumerable is an interface that allows us to have something that represents these kind of containers for data, right? So usually they're the ones that are kind of contain things in it. And this is what we use in .NET, right? So that is the implementation kind of the iterator pattern. And we have a bunch of like dictionaries, collection, like lists, arrays, um, and other things that are just about saying how we organize data, how we access this, and other stuff. So now you can look at the geometry element and understand its kind of idea, right? That it implements a given interface. Interface means some contracts, and yeah. So I hope that now it's way much clearer. Thank you everyone for watching. As always, like the video, subscribe to the channel, leave some comments down below. I would really appreciate it, and that would help the channel grow. Again, thank you for sticking up to the very end, and see ya.